This is going to be a boring video. No, not that kind of boring. There we go. All I'm going to do is show you how to simulate the universe on your own computer. We're going to be using After Effects, and it doesn't really matter what version you have as long as it's fairly recent. To start with, we need some initial conditions. We want to know what the universe looked like just after the Big Bang. So we're going to use the data from the WMAP satellite, which took pictures of the cosmic microwave background. You can get these images from the WMAP website, but they're in the weird egg-shaped Malvida projection, and we'd like them to be in the equirectangular projection. And there are ways of changing coordinates, but for now I'll provide you with a sample of CMB data. It looks like this. It's pretty exciting. Actually, you can even just use the fractal noise in After Effects, because that's what the CMB is, basically. It's Gaussian random noise. So anyway, once we have our CMB data image file, we'll create a new composition with it, and immediately we'll pre-comp it, because we're going to be using a particle plugin. To start with, let's clean up this data a little bit. So I'm just going to add some levels, just to make it a little bit more punchy, and that's within the pre-comp. Now in the main composition, we need to create just a blank solid, and this will rename particles, because it will contain our particles, and we will add Particle Playground, which is the basic plugin for doing particles in After Effects. To start with, if we play, we see we have this beautiful and annoying cannon, so we'll turn off the cannon. Now we have nothing. So we're going to use the grid to seed our particles. We want the grid to match the size of our comp, so it'll be 500 by 500, and say maybe we want 20 by 20 particles. Is that enough? No, let's go 40 by 40. Alright, now we have particles. Except if we play, we see that it creates a new particle at every position on every frame. So we want to keyframe these numbers and just go to the next frame and then set them to 0. So we only get one particle for each point starting off. And now if we play, they're all falling down because there is gravity. Now this is gravity like a constant force in the downward direction, which isn't what we want. We want particles to attract each other. So I'm going to turn this off and we will go to the repel section. And we want the particles to attract, so we'll just add in a negative amount on the repel. So let's do minus 0.1 just to start with. Now as we play it, nothing happens because the radius for the force to take effect is too small. So we'll set this up to 50, and hopefully that'll catch some nearby particles. This isn't realistic gravity. It's basically either you're attracted to something if it's relatively close to you, or you're not attracted to it at all if it's farther away. Real gravity falls off like 1 over r squared. But anyway, if we play this now, we'll see that the particles are indeed attracting each other. The ones in the middle don't move very much because they're pulled equally on both sides, but the ones on the outside get pulled in, and as we wait, we'll see a beautiful symmetric mishmash of particles. But this isn't really what we want. We want the particles to attract each other based on the density of the early universe, and so the bright spots on the CMB data that we used are high density, and the dark spots are low density. So we want to seed our particles using the CMB. So we can see things better, I'm going to turn off the CMB, add a white solid behind the particles, and make the particles black. Now we're going to set the persistent property of opacity of the particles. So we're going to use the CMB data as the source, and we will map the red to opacity. Now we see the places where the CMB data was brightest are dark black, and the places where it was darkest are faint. Turn it back on, and you can see that. So now if we simulate forward, we're still going to get the same thing because all we've done is affect the opacity of the particles and not their mass. So to affect the mass of the particles, we go into the repel settings, and we want to select using a selection map of the CMB data, and that's all we have to do. Now the particles that are darker will attract more, and the particles that are lighter will attract less. So let's play this forward and see what happens. So you can see that the particles that are darker are the ones that are attracting all the others to them, and the particles that are lighter are literally lighter, they're less dense. Now that we've got the simulation fairly well ordered, how about the color? To get the color nice, we wanted it to be really bright where the particles overlap and faint where they don't, because when the particles in the real universe come together, they heat up and you get bright things like stars. So to do that, we actually need to make these a little bit less opaque so that the brightness adds up. So I'm going to go back in here to our persistent property mapper and change the opacity max setting to something like 0.15. So now everything's going to be very faint, but that's all right. That's what we want. So now I'm going to go back into project and create a new composition and call it simulation with color. And to create the color, all we have to do is we'll create an adjustment layer. And the first thing we do is we add a levels to it. And that's going to allow us to control just how dark and bright these particles are. So we'll bring up the levels actually a little bit to make the particles more visible. Then we're going to color it. So we'll use Colorama. Oh, that's interesting. What we're going to do is we'll just change the output cycle from none to negative as our starting point. So that basically just inverts the colors. And then near the white end, we want it to be a little bit orange to match the Millennium simulation. So just pick your favorite orange. Okay, we have orange there. And then somewhere near the mid-darker end, we're going to make it a blue-purple, again, to match the Millennium simulation. So now I think we've ramped our levels up a little bit too much. And one last thing, I'm going to add on a fast blur to take off those hard edges of the particles. So just a blurriness of 1. And now, let's see what happens. look at this. These galaxies, or these dense spots, they're going to collide. And there you have it. Simulation of the large-scale structure of the universe on your laptop.